Thank you, Barbara. Well, also I want to acknowledge the Powell Center and also our sponsors and these people who gave me information to include into this talk. And you see, with the following talks, they're kind of integrated together. Wasn't a collusion, but I think there was some agreement at least. So anyway, this mid-continent seismicity has created quite the stir in the induced seismicity world. This is, although it's a simple plot of seismicity in California versus Oklahoma since 20, 30 years, looking into the details is not as simple as this. There are many things that really these plots could be modified by, and I list them there in terms of the separating the natural from induced, although this strongly suggests that a lot of this is induced. But you see there's no pressure data there, there's no fault data there, there's things that you have to take into account when you're looking at induced seismicity. As kind of an example, I got this slide from Mark from a Stanford group, and I put those two little boxes on it. But you look at really what is the whole hullabaloo about here. Almost all hydrofractures in that little lower left-hand corner in terms of magnitude and in terms of effect, size of faults and things of that nature. You step up to the injection-related seismicity. Yeah, there's bigger ones in each one, but a huge majority of the seismicity is occurring in these areas. You see there's small fault areas, small slip. That's good and bad. Sometimes it's hard to find those small faults, and also understanding the stresses and the stresses relative to the faults. Which ones they're all critically in the critical area, but are they oriented properly with everything else? As an example here, I showed this from the geysers, and looking at the events that occur relative to injection. You see these two, this is two big jumps in injection, and that's looking at the seismicity. But these are magnitude 3s. This is over a long time period. The magnitude 3s are actually going down over time, although the injection is going up. Injection is always going up. So sometimes it's not as simple a process that we're trying to figure out. So what are the questions that really, in terms of the mitigation, in terms of facilitating the development of energy projects and keeping it safe? And that is not an easy question to answer. There's all sorts of different things going on in terms of technical and public reaction, in terms of interaction of the regulatory agencies, the policymakers. And so is there an alternative injection strategy that it could be followed and safe at the same time? And then what is the mitigation? If you can have all these plans in terms of what you're going to do and lay out something to the regulators, but what happens if you fall outside of that boundary? Do you have a plan for that? So, okay, here are some of the challenges, some main challenges. Seismicity induced / triggered seismicity is very site-specific. It's almost different for every case. You're in a different area, you're in different geologic regimes, different stress regimes, different populations, things of that nature. You often have fuzzy boundary conditions. You know that you don't have perfect data, in other words. And data is the key here to understanding really what's going on. Different stresses, faults, varying levels of acceptability by the public. If you're out in the middle of nowhere, you probably don't have much of a problem. Variety of stakeholders. It may be upsetting, but necessarily damaging to them. So that is just as damaging to the project as if physical damage to the area. Often occurred in areas of no measured induced seismicity. The Geysers was famous for that. There was no measured seismicity of any sort up at the Geysers before they started doing injection. And it often occurs in rare instances. If you look at the 150,000 Class 2 wells going on injection, not all of them have induced seismicity. Not even a small part of them have induced seismicity. And it has to do, of course, with the stresses, permeability, pressure buildup, and all the things that we know about. It's a non-stationary process, you know. You can actually change the stresses, change the injection rates, change the pore pressures. You don't have the same things you do have in natural seismicity. And it's still under study. And of course you want to balance the risk with the needs, energy needs. Now, when you look at that list, you say, well, why would anybody even think about doing an injection study in induced seismicity? Well, there's a lot of good news, too. Induced seismicity is not a new phenomenon. It's been around with us for 100 years in various different types of applications, everything from mining to reservoir impoundment injections. The Denver earthquakes are a good example of it. We know the basics. We know that it occurs on faults. It occurs in areas where the stress is oriented in the right direction. There's a pressure perturbation. You're perturbing the natural stress. And so we know about that. And given a reasonable, every case that I've been involved with, given a reasonable amount of data, not an extreme amount of data or no data, if you can figure out you can figure out basically what is causing induced seismicity, and therefore it implies that it can be mitigated. So also the good news is the industry, the geothermal industry is already on board, but looking at the larger industries, the for example, oil and gas industry, they are doing quite a bit right now. I'm very encouraged with the amount of information that they're putting out there, amount of collaboration that they're creating. There's all these things, AXPC, American Exploration Petroleum Council. State's First Initiative is relatively new. It's a group of regulators from different states collaborating with the industry to identify these issues and try to help and control it. There's many industry trade groups. The science is advancing rapidly. There's an economic driver for that. If you understand really the induced seismicity, it's really a tool also. It's not just a hazard, it's a tool for understanding injection type of activities and how to optimize your injections and get the energy out of the ground. And it's been my experience that if you keep everybody informed and you lay out the risks, you lay out what you know and what you don't know, almost always everybody and what your plan is, the resistance goes down, both from the regulation side and both from the public side. And pointing out last but not least, damage events, really damaging in the sense of structural damage from the civil engineering type are extremely rare. So what are the current practices right now? And what's the basic philosophy behind these practices? One size does not fit all. There's no doubt about that. The last thing you want is somebody coming in and saying, all right, everybody must do this in order to control induced seismicity before we're going to let you go forward. That is probably the worst thing can happen, because probably it'd be from a group of people who are not experts in the field. And all best, no disrespect to a lot of our regulatory agencies, but they weren't built that way. This is a relative new area for them. And maybe it's a good thing that the national people aren't coming in yet. They still are interested. They are going from, they're kind of doing an adaptive type of process, where they're going from a screening. All right, are you going to do this in the middle of a big city? Are you going to do this near a critically stressed in the right direction fault? Are you going to have automatically hostile public, things like that? And if you get over certain, like, all right, does this pass the laugh test? Then you go to the more complicated procedures. And it's being regulated right now at the state and even local levels in the geothermal world, which I come from. Actually, the local communities actually give yay or nay to a lot of these projects. They're not as large as oil and gas, but they are larger in terms of injections, to tell the truth. There are a few suggested protocols, and these are suggested protocols. They're not meant to be regulation. DOE is not a regulatory agency. USGS is not a regulatory agency. And so these are basically set out there, say, all right, this is what we know. This is what we think you should be doing before you inject large amounts of fluid. This is what types of things you should investigate. And they are not set in stone. They are flexible, they're meant to change, and they're meant to be updated as the new knowledge comes about. And BLM and EP, however, are developing, quote, permitting procedures, mainly for the geothermal and carbon sequestration world. I haven't mentioned too much about carbon sequestration because it's not very far along, actually, in terms of this type of activity. They're looking at a small part of it, actually. So here's an example, for example, and I'm not going to read all these, but the one thing I want to draw attention to these things All of those first bullets, except the last bullet, have nothing to do with really a technical approach. It's all community interaction and information and interaction with the community back and forth in terms of keeping people informed, looking at also an independent data analysis too. So there's still a lot of suspicion by the community, which Calpine has successfully dissipated by saying, all right, we're going to let independent agencies and DOEs in this too analyze the seismicity and make it public. There's a public website, a real-time website for this, and the community calms down, the regulators calm down. When the community calms down, the politicians calm down. And so that's an important point. And at the end, well, then they actually do modify the injection to keep it apart, the large events away from the nearby community and keep the small ones closer to the community and still successfully operate the field. Oklahoma Geological Survey, one of the authors, this is from Oklahoma, Austin, Holland, and I've paraphrased this, but these are the things that they are recommending to the operators to, not regulating, recommending to the operators to essentially, this is the type of things you should keep in mind when you start injecting fluid into the ground. And the operator should stay in a plan. Okay, have a plan. Because the community invariably will stand up and say, well, you've said that you're going to have this seismicity and you're going to do this. What if you don't? What are you going to do? And so that's where, if you have a plan and you can convince the community, the regulators, the politicians, whoever, that you have a plan, it's a credible plan, and well explained too to the community, then you're on better ground. And however, all of these things do require data. And you'll see this account, that's a theme through this talk. All right, this is a slide I got from Exxon Mobil as part of these, basically these industry groups that I mentioned, in terms of, all right, how do we determine the hazard associated with this? These kind of mimic a lot what I've been talking about. Avoiding injection agents identified as significant false trends. Well, how do you do that, you know? A lot of this is in the details. And it depends on, again, depends on where you are, how much concern you should have. If you're 20 miles away from the nearest structure, you're probably not as concerned. And if you're not injecting large amounts of fluid, and you're not injecting into the basement, and you're not doing this and not doing that. And then education and training, that's very important. So a slide that I got from the working group around AXPC is, again, it's a screening process, and it goes to mitigation, looking at the different steps that one needs to take. And it's kind of a loop a little bit here. If you go to the next slide, you see, all right, same thing. You see the same themes running through all these things. High impact site. Is it a high impact site? In other words, are you in the middle of a city? Are you underneath a hospital? Are you wherever? You know, you have to identify where you are. Has there been induced seismicity in the past in these areas? If you answer yes to some of these, you go to the next step. And then you might be able to just get away with just stopping there, okay, if you've identified all these things. Or you need to maybe go to the more sophisticated parts of the best practices and protocols that the geothermal industry and the National Academy recommended in their study. So it just depends, really, it just depends on the site. And so what are the things that should you be worrying about? And these are some of the things, okay, again, they all require data. Do you really have 4D investigations data? When you look at this and say, all right, should the companies be doing this? Or if you're a company and say, should I be doing this? Well, you may not necessarily have to do this. But one of the concerns that I have and other people have is, what about the smaller operators? What are they going to do? What can they afford to do? How do you still keep it economically viable in order to either to dispose of fluids or to be actually using fluids to enhance the energy output? The larger companies can probably afford to do this, but what do you do about the smaller companies? And so that's kind of where the scientific community comes in terms of interacting with the entire industry, the fluid injection industry. And so a lot of the times those are mutually exclusive, but you'd be surprised how open to most companies are in terms of setting up collaborative type of projects. So, all right, BLM. I mentioned the BLM approach on a national level here. This is what they are doing for the geothermal world. And the reason they're doing this is they basically have a directive from their boss, who is the Secretary of Interior, to facilitate energy production through geothermal. And so they have been struggling and it's still in the draft form, in order to have a regulatory or a permitting process. The new word, the word I didn't know, is something called a FONSI, a finding of no significant impact. How do they issue a FONSI to a producer who wants to inject fluid into the ground? And it applies to any fluid injection industry, and they will probably move on to the oil and gas world. And so this is kind of what they have outlined in terms of what they would like to see before they issue a FONSI. They do not have internal expertise, essentially, to really get into the details. They're relying on the scientific community and their interaction with the scientific community to refine these. The goal was to have this by January 1st, 2015. That's not very far away, but I don't think they're going to have it. They look at past seismicity, location to people, things that are already in the National Academy and the best practices and the things that the industry is already thinking about. It's just a matter of getting the data out and going forward. So one of the things that's happening now, and this is a little bit of an international flavor to the talk, is that the adaptive traffic light systems. Right now, the traffic light systems are fairly static. Beforehand, you say, all right, we think we're going to have a magnitude X. And if we get a magnitude X minus Y, we're going to stop. And that hasn't been very successful in the past. It's relatively simple, and stoplight is simple. But what is really needed is a more technically driven, forward-looking type of adaptive type of methods where you're actually taking data. While you're taking data, you're refining an initial model. So you get the data, and you have a model of what the system's going to do. It requires some more sophisticated modeling of the system. This is not in place. The IEA and the IPGT, was the International Program for Geothermal Technology, have banded together. There's 3 countries involved with this: Switzerland, New Zealand, and the United States, in order to develop these stoplights. So they're more sophisticated, and they're more complicated, but they're hopefully more forward-looking and be more accurate. So what is needed? I'm finishing up here. Data and continuous communication. Data. It's easier said than done. It's not that the companies don't want to give. Sometimes they don't want to give it to you, but sometimes they have day jobs, you know, and it's difficult. It's in different places and things of that nature. In the Powell Center, we talked about a central data repository that people may have. There are these frac sites that are put in there, but are they required to put it there? Improved mitigation methods, tailored for different applications. Adaptive is one of those, but it implies a better fundamental understanding and modeling of IS. We don't perfect in our understanding of IS. We don't have that. Recognition by all stakeholders that induced seismicity is a major issue. It need not be a major issue if properly addressed. Technical needs, improving the knowledge. These are basically, we still aren't there in terms of perfect understanding of induced seismicity. I think we're to a point where we understand it enough to put bounds on the induced seismicity. Ground motion is not magnitude. It's important. It's a hard thing to get across to the regulators. I say, well, what size of earthquake can we allow? Well, it's not the earthquake you're worried about. It's the ground motion you're worried about. And it varies at every site. Establishing interdisciplinary, technically based methods, in other words, more research. And differentiating naturally occurring earthquakes for induced earthquakes. There's still some, in the Powell Center, we had some discussions about that. It was, well, what's the criteria for, say, this is natural or this is induced? At some points, it's pretty simple. At other points, it's not so clear. So economic drivers are really advancing this. The oil industry wants to get more oil and gas out of the ground. The geothermal wants to get more hot water and heat out of the ground. It's also a tool. So there's a really economic drive for understanding induced seismicity and how do you manipulate fractures. I think industry is on board now, broadly on board. How do you facilitate small operators with limited resources? You know, you just can't say stop. So what do you do? There are some acceptance, more being developed by the public. The scientific community needs to interface, I think, better with private and public bodies. The regulatory industry needs to say that, all right, we're not perfect in our knowledge of induced seismicity, still evolving. And so technical expertise needs to go both ways. And all stakeholders must communicate and make data available. That, again, is easier said than done. And the permitting are going towards, I think, in the right direction. Rather than thou shall do this, they're going towards, all right, let's have a stepwise process and really dictate, say, all right, if this is all you need to know in this situation, and the more complicated the situation gets, the more risky the situation gets, then they need more information. So anyway, that's it.
Do we have time for one quick question? Yes.
Do you know if the Geysers have investigated their activities in regard to the latest earthquake in Napa?
Yes. Oh, actually, we did. The earthquake in Napa caused the Geysers field to sparkle. If you look at the background seismicity of the geysers, it's kind of bumping along like this, you know, above a magnitude 0.5. It's kind of bumping along like this, around 20, 30 events per day. The Napa earthquake happened, then there was an immediate spike in seismicity up to about 200 events per day at a rate for about 2 hours. And then it fell down back to the background level. And it didn't happen, one big event didn't happen, it wasn't an aftershock sequence. It was sparkling all over the field, different sized events, and no particular time history to those events, other than the fact they happened right after the Napa earthquake. It was very interesting. It was very interesting. Now, it didn't do that when the Fukushima earthquake went by, waves from the Fukushima, and sometimes it does, sometimes it doesn't.